The third resource for understanding climate that we're going to be looking at is a program, a free program called Climate Consultant. Okay, so Climate Consultant resides on all the computers here. You can download it for free. It was developed by Murray Milne at UCLA years ago. Pablo LaRoche from Cal Poly, who some of you may come to know if you transfer over there, was involved in the development of Climate Consultant. Okay, as I said, it's a free program and you can download it for free. Just do a search for Climate Consultant download and you'll be able to download the thing. All right, so this is version 6.0. It just recently came out. Last year we were working with version 5.5. So it gives you some of the weather features, some of the features that, that you can look at in here. So right now, in order to jump into the climate component, I'm not going to review those with you. So I'm going to click on Next. Once you start it, this is the first screen you get. So for that, it's going to give you some instructions. Click Next. And I'm going to start a new project. Okay? And as a matter of fact, what I'm going to try to do here is I'm going to start 2 copies of Climate Consultant. Let me see if it allows me to do that. Let me pause this while I do that. All right, so it will not allow me to open 2 instances of it. Okay, so when you come to the first screen where you actually have to make some decisions, you're going to have to make a decision on whether you're doing non-commercial, small non-commercial buildings, or you're working on residential. Okay. Second thing that you're going to look at is whether you're working in BTUs and Fahrenheit degrees, or you're going to be working in metric, Celsius, and joules. Okay. So since we're here in the United States, we're going to continue to work with imperial. And what I'm going to do is I'm going to select a California climate zone data file. Okay. So I'm going to click on that, and again, the one that we're going to use is Climate Zone 10 for Claremont. Okay, so You
click on the 10.
You think so? There it is. Ah, there it goes. Open file. Thank you very much, Patul. Okay, so do you guys recall a discussion last week about EPS files and the content of the EPS files and also the use of the energy models? So the energy models rely on the data that's collected by weather stations, and this is the average data. Okay. If you take a look at it, there's several different things that are being collected here, and there are the months of the year. Okay, notice that we're working in BTUs per square foot, all right, for the units, and we're working in foot candles, degrees, and a number of different things. So you have your units for each of these measures on this side. You have the months along the top, and then you have the different categories along this side. Okay, so as it sits, this data is useful, but most of you think graphically, and so looking at the data in this format may not give you a clear picture of how to use it. So, for example, take a look at the ground temperatures, right? 56, 55, 55, 57, 62, 66, 69, 71, 70, 67, 63, and 59. What's that mean? Right? You could take a look at average temperatures or global radiation. Again, these measures in this sort of chart format are not as particularly helpful to a designer. So we're going to take a look at how Climate Consultant takes this information and puts it into a more usable format for us. There are some charts that we are going to use, and I'm just going to take the default, the California Energy Commission comfort model. This is the synopsis of it. We talked about that last week. All right. There are some charts in Climate Consultant that are going to be very useful, and there are going to be other charts that, for our purposes, for the beginnings of this design with climate, are not going to be something that we're going to look at too carefully. Okay? So right here we have a chart, and the chart is showing you a variety of different things. There's always a legend on this side. The legend is going to show you what all these various things mean. So one of the most important things that I want you guys to be aware of is this gray band that runs down the middle, the comfort zone. Okay? So the comfort zone came out of our energy model. So if I back up to that, okay, setting this number at 68 and that number at 75 is what changed, is what set that number right there. So for example, if I back up and I set it at 70 and 80, and I click next, see what happened to the comfort zone? It jumped up, right? So I'm going to try to undo that so that I can get back to more of the normal. All right, so there is, that's the way it sort of came out of the box, let's call it. Okay, so this is going to give you the recorded high temperatures by month. Note that this is months down in here. Okay. The scale along the bottom is the month of the year. The scale running up the side is the temperature in degrees Fahrenheit. So looking at January, does January look like a real comfortable month? It's not, right? Would you say that it's pretty cold? Well, relatively speaking, compared to most of Southern California, yeah, it's pretty cold. Compared to the rest of the United States, oh, hell no. There's people that come here from Minnesota and they wear shorts in that weather. Okay? Different things that you guys are going to look at. The average high, average low is this yellow band. Those were visible in a different format in WeatherSpark. When we looked at the temperature ranges, there was the average high, average low, and then there were percentile bands when we were looking at them earlier. Here, it's showing you in a bar chart format the same type of information. Okay? Design high and design low are the temperatures for which a mechanical engineer is going to design equipment. Okay? In regards to heat, they do not go all the way up to the record high. In regards to cold, they do go down to the record low. Okay? And then you have the average temperature, which is running in the middle, which is basically taking the halfway point between the average low and the average high, and it's giving you the average temperature between the two. That's halfway between the bottom of the yellow and the top of the yellow. It is ignoring the green. Okay? It's got, one of the things that I want you guys to be aware of with Climate Consultant is that it does have a variety of different sort of things that you can sort of click and change here. Okay? So I mentioned to you a moment ago that it works to the record low, but it doesn't work to the record high. Notice what happens when I change that button. Right? It takes the design temperatures all the way up to the top. And you can do the same thing for the low if you want to say, well, I'm willing to live with being a little cold and my heater not being able to keep up with things, then you can adjust that sort of right at that point. I think I better not make that quite so large. All right, so let's take a look at the next chart. The next chart is a much more complex chart. It is showing you the same type of information, right? This one is showing you month, 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 all along the bottom. But it's putting together several different things, okay? The blue band right here, is the average high and low and the record, or not record, but yeah, the average high and low from morning through the highest, the warmest time of the day back down to the coldest time of the day. Okay? So we talked about last week the notion of periodic behavior, right? We talked about a sinusoidal wave. Well, if you take a look at this red line, the red line is the dry bulb average. And you notice that the dry bulb average is halfway in between these things, right? So if we go back to the previous chart, right, the average temperature was halfway between those. So now we come over to this chart, And this is the picture of an average day in temperature swing for the month of January. So in the month of January, looking across at this thing, the average low temperature coming across here is going to be somewhere around 42 degrees. Does that look about right? The average right there. Coming across about 43, something like that. Let's back up and take a look at that. Yep, that's about right. The average low temperature is around 42 degrees. Okay? Going forward, the average high temperature, right, is somewhere around 80. And I think that's, no, I'm sorry, the average is the red line. So the red line says that the average high temperature is about 65 degrees. So once again, we'll go back and take a look at that. And yes, it's about 65 degrees. So you see the correlation between this chart and this one? So this is showing you an hourly depiction of what an average day looks like, right? In the record higher temperatures and the record lower temperatures and the average temperatures. And this is an hour by hour description over 24 hours versus this one that is just showing it to you as the average high, average low, and average temperature. Okay? All right. So there is the red line, which represents the dry bulb temperature. That's what the thermometer reads, and that is an average temperature. Okay? There is the black line, which is the wet bulb temperature. That, remember, that factors in relative humidity. And then there's all these things down here along the bottom. All right? And if you take a look at the legend for that, it's going to come in 3 different ranges. So global horizontal radiation is your total radiation on a horizontal surface. Okay? Now, but what do we mean by what kinds of radiation are we talking about? We're talking about, there's really 3 different kinds, but we're only going to consider 2 here. There is the direct normal. Now, so that you guys understand, direct normal means rays of light that are visible, that are actually striking a surface. Rays that would cast a shadow. Okay? The other one, the diffuse radiation, is light that's been scattered by passing through all the molecules of air and things that are in our atmosphere. So we have windows along the north side right here, right? Yes? Lauren, can you open that one, please? Careful. There you go. You notice how the room brightened up? If we had turned off the lights and turned the projector off, you would see a lot more brightness in this room than you did before we opened it, right? As a matter of fact, when we finish this presentation, we'll run the same experiment. Do you see any rays coming through? Do you see any sunlight coming through? But yet there is light coming through, right? That is diffuse radiation. Okay? So if it does not cast a shadow, a hard shadow, it's diffuse. If it casts a hard shadow, it is direct radiation. Okay? You have 3 of them. The global horizontal is the combination of the 2 put together. Okay? How this might influence something is it might tell you if a region is sunny or it's more cloudy. So if we compared this to Seattle, we would see a very big difference in the amount of radiation that's coming through the atmosphere. The diffuse radiation in Seattle would be much higher, and the direct radiation would be much lower. All right? So I'm going to stop this so I don't exceed my 15-minute limit.